Today we are going to discuss about the kinematics and dynamic analysis of mechanisms. First let us discuss basic things. So method of kinematic analysis. The velocity and the acceleration of links in a mechanism can be determined by two methods. One is graphical method, another one is analytical method. The graphical method is further classified into relative velocity, relative acceleration and instantaneous center method, Killin's constructions and complex and vector algebra. Okay. Yes, the relative velocity of two bodies moving along a parallel line, right? So consider the two body A and B. Consider the two body A and B moving along a parallel line in the same direction with absolute velocity VA and VB, right? Now then the relative velocity of A with respect to B is given by VAB, velocity of A with respect to B, right? So velocity of AB which is equal to VA minus VB, right? Velocity of AB which is equal to velocity of BA in the opposite direction, right? So velocity of A with respect to B and velocity of B with respect to A, right? Right. Similarly, the relative velocity of two bodies moving along an inclined line, right? So now consider the two bodies A and B moving with absolute velocity VA and VB, right, as shown in the figure, and then the relative velocity of A with respect to B or relative velocity of B with respect to A may be obtained by two different methods. One is the triangular law of velocity or the law of parallelogram of velocities, right? Now take any fixed point O, right? O which represents the zero velocity point, right? So from O we have to draw a vector OA, right? OA parallel to VA, right, and draw vector OB which is parallel to VB, right. So from fixed point we have to draw a line which is parallel to VA, vector OA, and from the same fixed point O we have to draw the vector OB which is parallel to the velocity VB, right. So with to some suitable scale, that's it. Then join this AB, right, to get the velocity of the triangle ABC, right. So see this arrow mark towards B. Now this is velocity of A with respect to velocity of B with respect to A, right. So maybe arrow mark in this direction towards A, then this is velocity of A with respect to B, whereas the arrow mark towards B, then which is velocity of B with respect to A, right. Both are same, velocity of A with respect to B which is equal to velocity of B with respect to A. The thing is only direction, right. Next, the motion of a link. Now let a rigid link AB rotates about a fixed point A with an uniform velocity, angular velocity omega, in the counterclockwise direction or anticlockwise direction. Here there is no relative motion between the A point and B point, as the distance from A to B remains same, right. So the relative motion of point B with respect to A must be perpendicular to the link AB, right. So velocity of B with respect to A, it should be perpendicular to the link AB, right. So therefore the velocity of any point on the same link with respect to any point on the same link is always perpendicular to the line joining of these points on the configuration diagram. So velocity of B with respect to A, it should be perpendicular to the link AB, or velocity of A with respect to B, it should be perpendicular to the link AB or the line joining of these two points on the configuration diagram. Here velocity of B with respect to A, which is equal to the vector of AB. So, which means the angular velocity omega into the length of the link AB, right. So, here the VB which is equal to length of the velocity of B with respect to A, which is equal to the length of the link AB and the angular velocity of the link AB, right. See, velocity of BA which is equal to the length of the link AB and the angular velocity of the corresponding link. The relative motion between AB, which is already we discussed, right. So, the velocity of any point on the link with respect to the another point must be always perpendicular to the line joining of these two points. Clear? Now, velocity analysis procedure by relative velocity method, right. So, see the picture, this is called as a configuration diagram. See configuration diagram here, in order to solve this velocity analysis by using relative velocity method, we have to follow these 4 steps, right. Draw the configuration diagram and calculate the velocity of the input link using the formula, and draw the velocity diagram and calculate the velocities of various another links, right. So, first step is draw the configuration diagram. Configuration diagram is nothing but it is a skeleton diagram or a line diagram which represents the given mechanism, right. So, this is called as a configuration diagram which represents the given mechanisms. To determine the velocity of various links of a mechanism, first we have to draw this configuration diagram of the given mechanism with some suitable scale, right. For example, this is 1:1, which means it's a regular normal scale, and 1:2 which is reduced scale, and 2:1 which is equal to magnification scale or enlarged scale. Okay. So, we can use these 3 scales to draw this configuration diagram, and the second one is calculate the velocity of the input link using the formula. In order to draw the velocity diagram, this is called as a velocity diagram. So, in order to draw this velocity diagram, the velocity of at least one link is required. So, usually in the given problem, the length of the link and speed of the links are given. Then the velocity of the input link, which means the velocity of the input link which is equal to angular velocity of the input link into the length of the input link, Here, according to this configuration diagram, the input link which is equal to velocity of, now I want to calculate the velocity of B. So, velocity of BA which is equal to the omega angular velocity of input link which is equal to here say they given omega. So, omega BA or AB into the length of the link AB, right. This is the formula. By using this formula, we can calculate the velocity of the input link, right. Then draw the velocity diagram. This is velocity diagram, right. So, by using the configuration diagram, draw the velocity diagram for the given mechanism by using this relative velocity method, right, that we will discuss with one example, right. Then last step is calculate the various velocities, of various links. So, by measurement from this velocity diagram, one can determine the velocity of any link of the given mechanism. So, we can this is called as VBA, which means we can calculate with the help of this formula, and from direct measurement we can calculate VCD and VCB, that we will discuss in our next slide, next videos. Okay. So, next one is the rubbing velocity at a point, at a pinpoint. What is meant by rubbing velocity? The rubbing velocity at any point is defined as the algebraic sum between the angular velocities of two links which are connected by pin joint multiplied by the radius of the pin, right. Consider two links, link 1 and link 2, okay, are connected by a pin joint at O as shown in this figure. Now, so say R which is equal to radius of the pin, omega 1 which is equal to angular velocity of link 1. Similarly, omega 2 which means angular velocity of link 2. Okay. So, link 1, link 2, two links are there, right? So r, which represents radius of the link, radius of the pin. So this is actually a pin, and we have to calculate the radius. So radius, which is equal to radius, r, which is equal to radius of the pin, omega 1, which is equal to angular velocity of the link, and omega 2, which is equal to angular velocity of link 2, right? Now see omega 1, which is the angular velocity of link 1, and omega 2, which is angular velocity of link 2, both are in the same direction or both are in the opposite direction, right? See, as per the definition, the rubbing velocity of the pin joint O, which is equal to omega 1 sum between angular velocities omega 1 plus omega 2 into, see here, sum between the angular velocities of two links omega 1 plus omega 2 and multiplied by the radius of the pin, multiplied by radius, which means r, right? So both are in the same direction. Angular velocities of two links are in the same direction, then omega 1 minus omega 2 into radius, whereas both are in the opposite direction, then omega 1 plus omega 2 into radius. Okay.